Hey guys, just want to run through a bit of a clarification of p-values and alpha. I was coming across as a little bit confused in the last video, so I wanted to try and clear that up with an example. It can be a bit confusing to word this kind of stuff, even though the maths is really simple. So let's say we have a hypothesis and we're going to run an experiment to test it. So our hypothesis is that exercise reduces anxiety. So we're going to have some sort of anxiety scale in which we would measure this. And let's just say that the mean anxiety level of the population is 20. What we want to see is a result where the population mean is less than 20, and we would conclude something about the population mean just from a sample mean. So we would take a portion of the population, because we can't measure everyone, obviously, and then we would run the experiment on them, observe their results, and then make a decision about how it relates to the population. So our null hypothesis in this example is when nothing systematic is happening. So when exercise does nothing. And that would be, we would have notation that the mean stays the same. The mean is still 20. Our alternative hypothesis is when something systematic is happening. So something is happening to the population. So that is when exercise does lower anxiety. And then that would be shown by here, the mean dropping below 20. So let's say the mean just does drop below 20. Like we've got a mean of 18. That's our, well, it should be technically be a sample mean, but new mean 18. So this is looking promising. Now, unfortunately, we got a p-value of 0.40. So this is really high. So this means that we would expect this outcome of the mean being 18 40 out of 100 times if the null hypothesis was true. So if exercise didn't even do anything, we would get this result that showed exercise lowering anxiety, that showed a group of people with a lower anxiety. So basically 40 out of 100 times is really high, so that doesn't really help us at all. It's impossible for us to make a conclusion. And we would base that on what our alpha is, whether or not we can make the conclusion. Now, normally alpha is 0.05. So in this case, p is greater than alpha. So it is too improbable that the event happened if the null hypothesis weren't true. Now, in this situation, we retain the null hypothesis and we can't draw any conclusions. Now, if however our alpha was 0.5, and this would never happen, this is just a really large value, so it gives us a lot of leeway to make statistically significant results, that p here would be less than alpha and we would reject the null hypothesis. So we would make a claim that exercise does actually lower anxiety from our results. However, the alpha is so big here that it wouldn't make any difference. The point that I'm trying to get at is the smaller the alpha, and they'll almost always be this or 0.01, that actually provides meaningful and statistically significant results, because we can see that it would be unlikely that our results occurred if nothing was happening. Thanks.